Okay, before I jump into the next example, I want to give you an equation for an ellipse. Okay, x minus h squared over a squared plus y minus k squared over b squared equals 1, where h comma k is the center, a is the semi-major axis, and b is the semi-minor axis. Okay, because I just sort of threw that out in the last segment. I just kind of threw that out, but I want to start with. I'm assuming you're an advanced student, but you might be starting this without a lot of background knowledge. Okay, so then I want to come in here, and I've got foci now. My foci are at 2, 5 and at 2, 1. Okay, so that means that my center is going to be halfway between those points. So I've got a center of, well, my x, I've got 2 and 2, so halfway between 2 and 2 is 2. Halfway between 5 and 1 is going to be 3. So I'm going to start here, and I'm just going to say that this is 2, 3. And then this is going to be 2, 5. And this is going to be 2, 1. And I have to know what the sum of the distances is. That has to be a given that I just got to make up. And so I think this is going to be not a nice one no matter what. So I'm just going to make it, the sum of the distances is, I'm going to make it 12. Wow, that's 6 to 10. That's going to be a little bit big. Let's make that 8. Okay, as soon as I know that the sum of the distances is 8, that tells me that A is equal to 4. Okay, so as soon as I know that A is equal to 4, I've got 1, 2, 3, 4. I've got a vertex there at 2, 7, and I got a vertex there at 2, -1. So this is my center, foci, and those are the endpoints of my semi-major axis. And then I'm going to go c squared is equal to a squared minus b squared, or b squared is equal to a squared minus c squared. And so I've got b squared is equal to 8 squared minus 4 squared. So that's 64 minus 16. I'm sorry, I always get that messed up. Remember that A is that, so it's 16 minus 2. Let me just write it out. Four squared minus 2 squared. Okay, so that's 16 minus 4 is 12. And so b is equal to the square root of 12. And the square root of 12 is 3.5. 3.46 exactly. So if I go over here from my center, I go 1, 2, 3, 3.5, 3.46. So that's going to be the point 5.46, comma 3. And then I gotta go 1, 2, 3, negative 3.46. So that's going to be negative 1.46, comma 3. And so those are the endpoints of my semi-minor axis. And then once again, I draw my potato. And this is why you have graphing programs, and so that you don't draw potatoes. But there's my potato. And so there's probably a better looking ellipse. So there's my ellipse that's got a center of 2, 3, and it's got a vertex of the semi-major axis at 2, 7 and 2, negative 1. And it's got vertices of the semi-minor axis at 5.46, comma 3 and negative 1.46, comma 3. And so my equation, if I plug my data into there, is going to be x minus 2 over that distance there, and that distance there is square root of 12, over square root of 12 squared, plus, oh, that's got to be squared, y minus 3 squared over that distance there is 4. 4 squared equals 1. So I'm going to have x minus 2 squared over 12 plus y minus 3 over 16 is equal to 1. So that's the equation of that potato ellipse.